Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering. So in this video, I'm going to discuss about the minimum spanning trees. So what is minimum spanning tree? So the minimum spanning tree for the graph, contour graph is a tree. So whose vertex should be same as the vertex of the given graph, and whose edges should be subset of edges of the given graph. So the weight of the spanning tree is nothing but the sum of the weights of all edges in the tree, and minimum spanning tree is a spanning tree with the smallest possible weight. So if I'm going to consider a graph here, so the spanning tree is nothing but the subgraph of a graph, and whose edge set should be the subset of edge set of the graph. So what should be the weight of the spanning tree is nothing but it should be the sum of all the weights of the spanning tree. And the spanning tree is this spanning tree with the smallest possible weight. Mainly this one is going to be applicable in traveling salesman program. So if I'm going to consider a graph like this, so for the possibilities of spanning tree looks like this. And similarly, what should be the weight of this spanning tree I want to find? So as for that, so I'm going to consider any one of the spanning tree, and the weight corresponding to each edge is calculated, and the summation of all the weight should be the weight of the spanning tree. And this spanning tree is going to be constructed by using two algorithms. So first one is Driscoll's algorithm, next one is Prim's algorithm. So what is Driscoll's and Prim's algorithm? So both the algorithms going to be different in the methodology, but eventually have the spanning tree. So the Driscoll's algorithm is going to be use the edges, whereas the Prim's algorithm is going to be use the vertex connections in determining the spanning tree. So this is the only difference between the Driscoll's and then the Prim's algorithm. So in Driscoll's algorithm, you have to use the edges, whereas in Prim's algorithm, you have to consider only the vertex connections and all. So in Prim's algorithm, the instance of the output is going to be represents the tree, whereas in Driscoll's algorithm, instance of output it may represent tree or not. So let us consider the first one. So first one is Driscoll's algorithm. So Driscoll's algorithm is nothing but a greedy. This greedy algorithm chooses some local optimum and then picking up the edge with the least weight. Driscoll's algorithm is going to work as follows. Take a graph with n vertices and keep on adding the shortest edge by avoiding the creation of cycles until n-1 edges have been added. So sometimes the two or more edges may have the same cost, and the order in which the edges are chosen, so in this case it doesn't matter. So different MS trees may result, but they will all have the same total cost, which will always be the minimum. So the Driscoll's algorithm will be as follows: Mag1. So take a graph of n vertices and they keep on adding the shorting vertex, so avoiding creation of cycles here. So until n-8. Until n-1 edges have been added. Sometimes two or more edges may have the same cost. So the order in which the edges are chosen, so in this case it doesn't matter, but different MSTs may able to result. But the cost of this spanning tree should be same and always be minimum. So how the Driscoll's algorithm work? So make a tree, empty tree, and repeat the steps 3, 4, 5 along as the tree contains n-1 edges and is not empty otherwise. So and step 3, you have to choose the edge of the lower cost and you have to delete the edge from the E. And if V, W does not create a cycle, then add view command ability to check. Otherwise, you have to discard this. So if it contains the fewer than and minus one, then more spanning tree is going to be produced. So this is the algorithm what I'm going to be following here. So for this, what I'm going to do, so initially I have to create an empty tree and I have to repeat the steps 3, 4, and then 5. So choose the edge of the lowest cost and then delete the edge, and finally have to be the edge does not form a cycle, then only I'm going to add it to the empty tree. So if a tree contains the fewer n minus 1 edges, then you have to explain the most spanning tree here. So let us consider a cycle. So graph. So in this graph, I'm going to be arrange all the vertices in weights of edges in ascending order. So among this all the weights in the graph. So what is the minimum edge that should be 10? So that's what I'm going to take here. And next minimum of 8 is 20. So 20 now 15 is there. So 15 is going to write here. So the edge is 3, 6. And next minimum of 8 is 20. So next one added. And next minimum of 8 is 25. So 25 added. Next minimum of 8 30. And next minimum of 8 40. 35 is also there. And next minimum of 45. And then next minimum of 8 50. And last one is 55. So like this, I have to arrange all weights of this graph in ascending order. And once these weights are going to arrange in ascending order, so next what I have to do, I have to take an empty tree, and then the edge what is there, so that one is hard to highlight it. So 1, 2, and next one is 3, 6, and next one is 4, 6, next 2, 6, and 1, 4. So if I'm going to take join 1, 4, it is going to form the cycle. That's why I'm going to reject it. And next one is 3, 5, and like this are going to be constructed. So once all weights are listed and what should be the sum of the weights of the spanning tree, so that should be the corresponding weights. So consider another example here. So in this one, consider a graph. So arrange the weights of this graph in ascending order in such a way that can able to insert one by one edge, which is going to have the smallest one in the graph. So first one is 10. So 10 is going to be inserted in the graph. And next one is 3, 4. So 3, 4 inserted. And next one 2, 7 inserted. So next one 2, 3. So if I'm going to join 2, 3, this does not form the cycle. That's why I'm going to consider 2, 3. And if I am going to consider 18, that is 4, 7, it is going to form the cycle. That's why I rejected here. And 5, 7 also going to form the cycle. That's why it should be rejected. And next one is 5, 6. So that one also inserted. Let's take another example. So this is the graph I'm going to have. So from this, so what is the minimum? First minimum is that 10. So 10 is going to be inserted. And next minimum is 12. So 12 is inserted. And next minimum is 14. Next minimum 16. Next minimum 22. And next minimum is 25. So like this, we are going to construct the spanning tree through Flickr's algorithm. Next one is this Prim's algorithm. So Prim's algorithm also famous for greedy algorithm. It is used for finding the minimum spanning tree of the graph. So in order to apply the Prim's algorithm, the given graph must be weighted, connected, and directed. Then the Prim's algorithm will work. So in order to find the minimum cost of the spanning tree, so we must be selective. We must always happy adding a new vertex for which the new edge is as small as possible. And this simple modified algorithm of spanning tree is Prim's algorithm. So how this Prim's algorithm is going to be constructed through the use of spanning tree Prim's algorithm. So what is the algorithm here? So randomly choose any vertex, and then the vertex connecting the edge having at least weight, and we have to find all the edges that are connected to the new vertex and find the least which whose vertex and edges is existing. And if you are going to be include that edge is going to create the cycle, it does not form it, otherwise you have to look it onto the next least edge weight. So repeat the steps 2 until all the vertices and the minimum spanning tree is going to be obtained. So consider a graph here. So in this graph, so I'm going to select 0 as the starting point, and then what is the minimum weight that is going to be connected from 0 to 1, 2, 3, 4, 5, 6. So I can able to select 1, 0 to 1, I can able to select 0 to 2 as well, and then 0 to 2. So that's why what I'm going to do is, I'm going to choose any one. So 1 is selected, and next one 3 is selected, and next one 8 is like 4, 6, 2, 5. So like this, we're going to construct the spanning tree by using Prim's algorithm. So by constructing the edges. So let us consider an example like this. So consider a minimum spanning tree for the graph. So in this one, what I'm going to do is, so initially I have to construct an edge of minimum weight. So 6 and 1. And next one is for 10 and 25. So that's why 25 is going to be inserted. And from this, what is the next move? I will have 24 I can able to choose, or I can able to use 22. So since you can the cards, I selected 2 here. And next minimum is 12. And next minimum is 16. So like this, we are going to construct a minimum spanning tree by using the Prim's algorithm. So in Prim's algorithm, what I'm going to do is, so initially select the minimum weight and then apply to the next minimum. What are the adjacent, that is 1 is 2, or I can able to use 5. And again in this, we're going to select the next minimum is 22, 18, 12, and then 16. So what is the minimum edge cost of this spanning tree is nothing but 10 plus 25 plus 22 plus 14 plus 2 plus 16 plus 12. So what is this weight? That should be the minimum cost of the spanning tree. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.